Welcome to an extravaganza. This is an animated mind map on the atom. So let's kick it off and write down, a bit thick there, a bit like myself, the atom. Now the atom is one of these things that goes way back. For example, if you were a Greek, they thought there was four: earth, wind, fire. Any of you look that up? Earth, wind and fire were abandoned in the 70s, just in case you're ever interested in that. And the last one was water. And they thought that was the four elements that there was. Fair enough. So today we think there's 100 plus elements. Some people would argue that some of them aren't elements because they don't exist that long. There's 100 plus elements. And it's all coming from dear old Dmitri Mendeleev. And Dmitri more or less set up the periodic table as we know it today. There are words afoot now that the periodic table may be changing. So before you die, it'll not matter to me, before you die, the periodic table may change. So these 100 elements were believed, when the alchemists were working, that there were solid spheres. But today, that more or less changed about 1919. And if you knew any of history at all, 1919, they had the First World War. Well, it was over, but again, wars always spur on science. And there was a fellow called J.J. Thomson, and he suggested, along with a fellow called Niels Bohr, probably boring as well, but Niels Bohr suggested that it wasn't a solid sphere, but that it was made up of this thing called a nucleus. Now, see, whenever we draw these nucleuses, we are really very wrong. Now, a nucleus is the size of 10 to the minus 15 of a metre. Now, that's wee. Right? That's known as a femtometer. Something for you to learn. So let's go down through them. How do you know it's wee? Follow the blue spot. Do you see the minus 15? That tells you it's wee. It tells you there's 15 knots in front of that 1. That's wee. So we'll start off where we know. Milli. 10 to the minus 3. Millimetre. A thousandth. 10 to the minus 6. Micrometre. Now in our world, a millimetre is maybe the thickness of a human hair, and we don't really know much below that. A micrometre means nothing to us humans. 10 to the minus 9 is a nanometre. Now a nanometre is the size of an atom. Nanotechnology and all that bump that goes with it. 10 to the minus 12 is known as a pico. A picometre. So follow the blue spot. That's the size of an atom. And there's the size of the nucleus. So the nucleus is 1,000,000 times smaller than the atom. So if you said a pea was a nucleus, well then, and roughly p is roughly centimetre in diameter, well the shells would then be 1,000,000 centimetres. 1,000,000 centimetres is where the shells are. So in our world, this diagram is absolute rubbish. So the best we've got is all we can go with. So we know that the nucleus is a femtometre. And in this nucleus there are things called nucleons. Right? Nucleons. And this is where I go high tech here. The nucleons are split into protons. So we'll just talk about protons. And here he is, my dear old friend, Peter the Proton. Imagine that. Huh? Looks quite well there. They always seem to sport hats, which I can never really understand. But there you are. There's Peter. And his friend, but not really. Don't let it screw yourself. His friend was Neville the neutron. And there's Neville. As you can see, quite similar to Peter. His old Neville, same hat, but he's just a blue chap. And these nucleons follow the blue spot. See, if you ever look at the page, see the blue spots. The nucleons are split into protons, Peter the proton, and neutrons. And these, the collective noun for these things found in the nucleus is nucleons. Protons and neutrons. Now, we'll go back up here again. Electrons spin round on these shells. Now, again, look, I'm telling you now, that is a poor diagram, because that's roughly a centimetre in my world when I'm looking at it now. So this has to be 1,000,000 centimetres away. See the distance from there to there? That's 1,000,000 centimetres away. So that shows you how good this diagram is. But these are called shells. You might have done a bit of that in chemistry. But for those who go on and do A level will find that you're going to be told a lie later on. So shells are where the electrons spin. And again, an old friend of mine, and he is an old friend of mine, is Bertie the electron. Now you would say, like, I had Peter the proton, I had Neville the neutron, and now I've got Bertie the electron. Well, the news is, a long time ago, whenever I was inventing Bertie, his name should have been Ernie, but I didn't make him Ernie, so you get the name Bertie, and that's the way it stuck. Sorry about that. Bertie the electron, right? So Bertie the electron, he lives on the shells. If you were given Bertie's address, it would be Bertie. He doesn't have a surname. Bertie on the shells orbiting the nucleus of an atom. Go down here. If you were given Peter's address, Peter proton, nucleus, the atom, right? If you were given Neville's address, Neville the neutron, the nucleus, the atom. Fair enough? Now we're going to compare these things, and I'm going to do a small table here. So I'm going to put in the word particle, and there are 3 particles that I want to look at. There's the neutron, neutral, no charge. There's the proton, dear old Peter. And then there's my dearest friend, Bertie the electron. And there's a thing here that we're going to look at, and it's called relative. A bit like your granny. Your granny's a relative. Who's your granny? Well, your granny's either your father or mother's mother. That's your granny. That's how she's relative to you, through your mother or father. So when we talk about relative here, we're comparing them to each other. So your granny is really compared to your father and mother. So it's relative means compared to each other. Now, if you were doing A level, you would know that the mass of the electron is 9.1 by 10 to minus 31 kilos. Now that is wee, right? 10 to minus 31. So there's a 9 with 31 noughts in front of it and then the decimal point. So that's wee. A proton is a lot bigger than that. Well, a lot, but we'll see now in a wee minute what you mean by a lot. So we're going to draw the table. And again, the first thing we're going to look at is the mass of them. Now, if you compare Neville to Peter, they're the same mass. Both have a mass of 1. But Bertie, dear old Bertie, Bertie's a wee skinny fella. Well, extremely skinny in fact. So he's 1 over 1836. Sometimes you see that as 1 over 2000. He's almost 2 thousandths of Peter or Neville. So he's terrible wee skinny fella. So now we're going to look at the charge. So Neville the neutron has no charge. Peter the proton has a charge of +1. Now and the electron is -1. Now look, relative. These two, the proton and the electron, have the same size of charge, but they are opposite in charge. And the neutron has no charge. And this is very important. If you went on to do A level, you change these figures. They are the same charge, only this is a positive charge and this is a negative charge. Fair enough? It's a very important table. You could either sit down and learn that, or you could tattoo it your mother might be a bit upset at that. So let's go up here and have a wee look. Maybe if your granny, who's relative to you, if she did that too, maybe you'll get away with it. So now I'll go way up to the top of the page here, and I'm going to look at these symbols and see what they mean. And I'm going to link these symbols down to the protons and neutrons and the electrons. Right, so I'll back up. Good man yourself. Here I'm going to look at helium. Right, so the helium, that's the symbol for it, He. Some of them are old symbols, like plumbum for lead. That's where you get the word plumber. And it's a Latin. Argentium for silver, fair enough. And then you get things like Americum. Well, that's a new one. Einsteinonium, that's a new one, so you can get the general gist yourself. So there's your symbol. Now this bottom number is known as your atomic number. And the atomic number tells me the number of protons. That's what it tells me. It tells me how many protons are in the nucleus. Fair enough? It tells me how many Peters live in the nucleus. That's the number of protons. Are you with me? Right? The 4, that's known as your atomic mass. And the atomic mass number tells me the number of nucleons. Now remember the nucleons, they're down here, look. Protons, August neutrons. So there's protons and neutrons. So say I wanted to draw the helium atom. Now again, I'm going to draw the nucleus, but again, that's 10 to the minus 15 of a metre. That's wee. That's 1 with 15 noughts in front of it and then drop the decimal point. That's wee. And then I'm going to draw the shell. Now there's the shell, but this is not drawn to scale, but it's all we have, because we can't draw it anyhow. That's roughly from there to there, follow the dot, from there to there is 1,000,000 centimetres, and that's a centimetre. It's hardly drawn. The geography department wouldn't be too happy at that scale, like. So let's have a look, go back up here. I've got 2 protons, so I'm going to draw in 2 protons. And because I'm high-tech today, I'm going to see, can I colour them in red? What am I doing there now? You know, have a look. Now they're red. By jeepers they are. And dear old, so I know I have 2 protons. There's it there, look. I know I have 4 nucleons. I have 4 things in the nucleus. 2 of them are protons, so the other 2 must be neutrons. And because we're high tech, that wasn't such a good idea. That. There's your 2 neutrons. Yes? So let's think of the pen. Always think of the pen. P-E-N. There's 2 protons. Now you see when you're doing questions, you watch the slippy examiner. He'll try to dupe you in these colours. You always remember that. I told you, slippy examiner will try to dupe you in this. You get 1 over on him or her. You know what you're at. Now, in this case, there's 2 neutrons. And because it is neutral, there is the same number of electrons as protons. So there's 2. Fair enough? And that's more or less all you have to know about the nucleus. If I was you, I would watch this animated mind map maybe twice. I would try to draw it out, and I would sit down and I would learn it. Learning takes time. Work beats brains when brains won't work. See you shortly. Doodle bit.